All right, so let's try one example problem that involves torque and rotation. We have a disk of radius 0.5 meters, it's drawn on the side, that's free to rotate without friction. String is wrapped around the disk, it's pulled with 2 newtons of force. If the disk has a rotational inertia of I equals 1/2 mr squared, we're going to find the angular velocity after 1 second. So a lot of stuff going on here, but the first thing that we need to start recognizing is which equations we can use. So this definitely talks about torque, and we know that torque is equal to R times F. It's also talking about things like finding out the angular velocity, which means this is probably a kinematics problem, and we're probably going to need to be able to figure out the angular acceleration. So the formula for angular acceleration is the sum of the torques over the rotational inertia. We also have in the problem the formula for the rotational inertia, 1/2 mr squared. And finally, we're trying to find angular velocity after 1 second. So this is going to be a rotational kinematics problem. We have a couple different kinematics formulas we could use. We could use omega equals omega naught plus alpha t. And that's the one we're going to use. There's two more, but this is the one that has time in it. And we don't have anything in our question about angular displacement. So this is the right equation for us to use. So our job now is just to turn all of these equations into something we can use. The first option is we could do it step by step. We could just say, okay, torque is R times F. So the torque would be equal to R, that's 0.5, times F, that's 2 newtons, oops. So this works out to be 1 Newton meter. Then we can figure out the rotational inertia. The rotational inertia I equals 1/2 times the mass of the disk. Oh man, there's no mass of the disk here. All right, let's make the mass of the disk 2 kilograms. That's my mistake. So the mass of the disk is 2 kilograms times, let's see, r squared. The radius is 0.5 squared. So that works out to be 1/2 times 2 becomes 1. So this is 1/4 kilogram meter squared. Now that I know the rotational inertia and the net torque acting on my system, I can figure out what the acceleration is, or the angular acceleration. That's going to be 1 divided by 1/4, because that's the torque over the rotational inertia, and that comes out to be 4 radians per second. Finally, I can go to this problem here now, and I can say the final rotational inertia is going to be, let's see, omega naught is 0. It's starting from rest. I don't think I said that, but it's starting from rest. Plus alpha, we figured out was 4 radians per second. And then finally, the time that it's spinning is 1 second. So its rotational inertia after, angular velocity is going to end up being, oops, that should be per second. This should be per second. Yeah. So 4 radians per second is what the velocity ends up being. Okay. So that's how we would solve that, just like stepwise, just figuring out what we can do as we go. Or we could start combining equations. We could combine equation 1 and 2 first and say alpha equals R times F over I. Then we could combine this equation. We'll call this one, I don't know, equation 1 prime. We can combine that with 3. And we would get alpha equals R times F over 1/2 mr squared. Could simplify that a little bit. The r cancels, or one of the r cancels out of the top and bottom, and I just get 2f over mr. And then now I know the angular acceleration, so I can plug that into equation 4. So I'm going to put equation 1 double prime into equation 4. And we will get omega equals, okay, so we already said this was 0. So it'd be 2f over mr times t. So that's 2ft over mr. And we know all the values. That's 2 times 2 times 1 all over the mass I said was 2. the radius is 0.5, and that ends up being 4 also. So you can do it either way, but there you go. There is an example problem that is using torque, rotational inertia, and rotational kinematics. This is very, very similar to a question that you should expect to see on the AP exam if they have a question that's testing for your understanding of rotational kinematics. They would probably bundle all of these things together. So thank you for watching, and I hope this helped.